I have a function. The function is f of x. Consider the value a where the function begins. What is the y value of the function? F of a, thank you. I also have a b value of the function. What is the y value? F of b. The average rate of change is determined by the secant line. Secant line connects 2 points, not 1 point. That represents the average rate of change. The slope of the secant line represents the average rate of change. The tangent line indicates the instantaneous rate of change. I need a volunteer. Who's my volunteer? Thank you, Logan. Okay, so I'm going to move this pen from point A to point B. At some point, I want you to tell me to stop. Tell me to stop when the slope of this would be the same as the slope of that. So I'll help you get started. Are you ready? Let's look right here. If I look at that slope, is that the same as this? No. If I look at the slope here, is that the same as this? You tell me when I get to a spot where you think it would be about the same. Well, is he qualified? Is he? Okay, we'll try again. Okay. Kind of fun, huh? Never know what I'm gonna do. Okay. That's the idea of the mean value theorem. Now, here's what we know. That point C sits somewhere between A and B. Furthermore, what we know is that f prime of C, the derivative at that spot, is equal to, anybody have an idea? The slope of the secant line. How would I represent the slope of the secant line? F of, how do we find slope between 2 points? y2 minus y1. What's y2? F of b minus f of a over b minus a. Mean value theorem is a beautiful thing. Let's write down the meaning of the mean value theorem. It says, let there be a function. No, not that. Let's try. No. Let there be a function that is continuous over the interval AB. What does it mean to be continuous over AB? You can draw the function without picking up the pencil, okay? Let there be a function that's continuous over AB and differentiable over AB. So we used We use parentheses there because we're not differentiable at the endpoints. Okay. Then there is C in the interval AB such that f prime of C is equal to f of B minus f of A all over B minus A. The question was, do you have to memorize this whole definition for the test? No, you do need to know the conclusion of the mean value theorem for the test. The conclusion of the mean value theorem is this right here. It says f prime of C is equal to the average rate of change over the given interval. And you can memorize that. You should understand. You should be able to take this and put it to a picture and know exactly what that means. That's important stuff. We're going to get started with a basic example right here. It says, consider the functions below. Estimate a value C in the given interval that satisfies the mean value theorem. I have these endpoints. I'm going to connect the endpoints. Who wants to be the next volunteer? Logan did it once. Who's the next volunteer? Shania. Shania, you tell me when I get to the spot. She's not even doing math right now. She's doing something else. You tell me when I get the spot on the graph that you think the derivative will be the same. Can you do that? Okay, you tell me. Yeah, good. Is there another one? Yeah, there's another one. Maya? Now, in this situation, we are approximating it. So we're going to say that C is approximately two different values. We would say about -2, and we would say about 4. Okay with that? Could you do that kind of a problem? Well, let's look at the next one. I'm going to join the endpoints to form the secant. I'm struggling there, but we'll try that. Okay, who's my volunteer now? Ashley, okay? Ready, Ashley? Oh, she doesn't want to do it. Who's helping me out? You got it? Thank you. So Riker says right away, hey folks, he says, yeah, he says this is the easiest problem of all. He says, look at the initial conditions. Let there be a function that's continuous or differentiable. True or false? True or false? This function is continuous. Okay, we're going to let you really think about this, folks, okay? We're going to let you really, really think about this, okay? True or false? This function is continuous. True. True or false? This function is differentiable. Why is it not differentiable? It's got a corner, and it's not differentiable at the corner. In order for a derivative to exist, the derivative from the left must be the same as the derivative from the right. That does not happen at a corner. And so we would say the mean value theorem does not apply. That's very important for us to understand. Let's flip it over. Says, use the mean value theorem to find the equations for lines tangent to the curve that have slopes equal to the average rate of the change of the function over the given interval. Confirm your answer by graphing the function of the tangent lines. Provide a rough sketch of the graph. We're not going to do all these pieces, but we're going to do parts of them, just frankly because we don't have enough time right now. Sorry about the lack of the appropriate parenthesis there. I'll put a bracket on the end there. So what we say is that this shape, what is that shape? It's a parabola, okay? All right, it's upside down parabola. And I don't know exactly what the endpoints are, and this isn't the actual graph, but again, the idea is that this is the average rate of change. We'd like to find the spot where the instantaneous rate of change is the same as the average rate of change. So how do we do that? We use the conclusion of the mean value theorem. It says f prime of c, this you need to memorize, is equal to f of b minus f of a over b minus a. Let's set it up. What is b minus a? Negative 5. 1 minus negative 4. So positive 5, right? How do I determine f of b? Plug in 1. You plug in 1, what do you get? Negative 7 minus. Now we plug in negative 4. We get negative 4 squared is 16 over, I'm sorry. Jumping ahead. Negative 16 minus negative 24, so plus 24, right? And so you get 8. So what I have on the left side is f of b minus f of a over b minus a. On the right side, we're going to put f prime of c. What does that mean? Take the derivative. What's the derivative? Good. All right. So what's the left side? Negative 3 is negative 2x minus 6. Add the 6. X is negative 2/3. Somebody tell me what that means at all. Sorry, negative 3x. What does that mean at all? That's your C value. What does that mean that that's C? At that point, the slope is the same as the average rate of change. Exactly. Ashford's got it. Okay. Now, here's what I'd like to check. It says that this value, negative 3/2, should fall within the interval. Does negative 3/2 fall within the interval of negative 4, 1? It does. So I have a good indication that I'm off to the right start. Okay. We'll do one more, and then you start part of your assignment, then we'll have to finish the other part. Okay. So f of b f of b 2/7 minus f of a 2 over 6 is equal to, what do? We got two options. Let's do chain. So I write as 2 times x plus 3 raised to the negative 1. Chain rule, 2u to the negative 1 and x plus 3. What's the derivative of 2u to the negative 1? Negative 2 over u squared. So I get negative 2 over x plus 3 quantity squared. So now that becomes the equation I'm trying to satisfy. So 2 over 7 minus 2. I'm going to try to make sure I've got common denominators here. So I've got 14 over 7. So I end up with what? Negative 12 over 7 over 6 over 1 is equal to negative 2 over x plus 3 quantity squared. How do I simplify this complex fraction? Multiply it by the reciprocal. If you multiply by 1 over 6, I'm just going to get a negative 2 in the numerator, correct? Times 1 over 6, you can see that that will cancel. So I get negative 2 over 7 is equal to negative 2 over x plus 3 quantity squared. Do you have an idea how I might solve this? Cross multiply is a great idea. Negative 2 times x plus 3 quantity squared is equal to negative 14. Divide by negative 2, x plus 3 quantity squared is equal to 7. Now what? Square root both sides. I get x plus 3 is equal to, because I square rooted something that contains a variable, I have to list both solutions. That will be the positive and the negative root of 7. Subtract the 3, x is equal to negative 3 plus or minus the square root of 7. Are you confident there's two answers? Should we check? We better check, folks. We take out our calculator, negative 3 plus the square root of 7, and I get, is that within my interval? Negative 3 minus the square root of 7, is that in my interval? No, so you've got one solution. It's x is equal to negative 3 plus the root of 7. That's your C value. Second of all, I want you to look at the original function. Where is the function not defined? Is this function continuous for all real numbers? No, where is it discontinuous? Negative 3, okay? Is negative 3 in our interval? No, so the mean value theorem does apply, but if our interval was negative 4 to 4, we would say mean value theorem does not apply because it's not continuous over that entire given interval. See it? We pause. Okay, look at number 4. So we've got an interval from 0 to 3 pi. What's different about this one is the trig function. We've got to keep a little bit of trig in what we're doing, otherwise we forget it. So I'm going to set up f prime of c is equal to f of b minus f of a over b minus a. So let's start with f prime of c. How do I find the derivative of 3 sine of x over 2? Chain rule. So I have 3 sine of u. I have x over 2. Derivative of x over 2? Ugly. So x over 2 is the same thing as 1/2 x, right? So what's the derivative of 1/2 x? Half. And derivative of 3 sine of u is 3 cosine of u. So we get 3/2 cosine of x over 2 is equal to, now I have to do f of b minus f of a over b minus a. If I plug in 3 pi, anybody know the sine of 3 pi over 2? Negative 1. Very good. Times 3 is negative 3. Now I plug in 0. And I get 0. Over, what's b? 3 pi minus 0. So we're trying to solve this equation. 3/2 times the cosine of x over 2 is equal to negative 3 over 3 pi or negative 1 over pi. How are you going to start solving that equation? Multiply by 2/3. Cosine of x over 2 is equal to negative 2 over 3 pi. Do I get rid of the 2 next, or do I get rid of the cosine? How do I get rid of a cosine? Cosine inverse. Is cosine positive or negative? Cosine is negative. And which quadrants is cosine negative? Second and third. Very good. When you have multiple solutions with the sine and cosine, just come up with one of them, folks. That's fine. Just come up with one of them. Okay. We won't make you do all of them. I'm sorry. We'll do the 2 within the 360 degrees that come up. But sometimes there's actually 4, 5, 6. Just do the first 2 that come up. So I'm going to cosine inverse. I'm going to make sure that I'm working in radians and not degrees. So I'm going to second cosine inverse, and I'm going to do 2 divided by, and make sure that you use your parentheses, otherwise you'll get it wrong. 2 divided by 3 pi. We used up the negative when we determined that was the second and the third quadrant. So I press enter, and I get 1.35. 1.35 and 1.35. So we're working in radians. Anybody know how many radians we have right here? That's 180 degrees. What's 180 degrees in radians? 3.14. So if this is 3.14, what do I do to come up with that angle? Subtract 1.35. So 3.14 minus 1.35, and I get 1.79. And how do I come up with the next one? Add it, 3.14 plus 1.35, and I get 4.49. So when I got rid of the cosine, what I have left is the x over 2. How do I now solve for x? So x is equal to, anybody, 1.49 or 1.79 times 2? 3.58. And if I take 4.49 times 2, 8.98. Do those both fall within the interval of 0 to 3 pi? Because 3 pi is more than 9, or is more than 9, right? So it looks like we found our C values. Okay. So the last part for us to examine. Yes. So the question is about why didn't we do anything with the negative 2 over 3 pi? And we did. What we did is we did the cosine inverse of 2 divided by parentheses 3 pi. We did not choose the negative because the negative determined that we were in the second and the third quadrant. And when we did that, we got the 1.35. Yeah. Don't feel bad. All right, last example. We want to be able to figure out these type of pieces. It says, consider the following tables. Let f be continuous and differentiable. If f is continuous and differentiable over the entire interval, okay? The question is, does there have to be a value c in the interval such that f prime of c is equal to -2? And I actually want to change this. I'm sorry about it. We're going to change this value because I didn't like the way the problem worked out. We're going to change it. Yeah, actually, -2 is perfect. Yeah, no, -2 is good. And so what we're finding here is if you look at the table of values, we don't know exactly what this looks like, but I'm going to try to create just some type of representation. -2, 9, that would be back 2, and it would be up 9. And then it would be over 1 and up 16. And then over 3 and down to -1. So the graph looks something like that. At some time, does it have to have a slope of -2? Why? Because f of b is -1. And f of a is 9. B is 3. A is, and you get which is, I just about guarantee you're going to get at least one question like on the AP exam where it says, look at the table and determine by the table, does it have to have a slope of -2? So we heard the easy comment. Let's go here now. Does there have to be a value such that the derivative is equal to 0? Yeah, the slope changes from positive to negative. So does it have to cross over 0 at some point? Yeah. Yep. So in this case, we would say the mean value theorem guarantees C exists. In this situation, we would have to say that the slope changes from positive to negative. And if it changes from positive to negative, does it cross over 0? So I'm going to ask you another question, though. Does there have to be a spot where f prime of c is equal to 10? As you look here, what's the rate of change happening here? What's 16 minus 9? 7. What's 1 minus -2? 3. So we get 7/3 for that rate of change, right? So that's like 2.33. So does it have to at some point have a rate of change of 10? It wouldn't, would it? So we can't guarantee that. Let me ask you one last question, see if you really understand this piece. I'm not going to give you a derivative. Does f of c, not the derivative, but does f of c at some point have to equal 4? Why? What's the height of the function here? 9. What's the height of the function here? 16. What's the height of the function here? If it goes from 16 to -1, does it have to cross over 4? What theorem told us that? It was the intermediate value theorem. The intermediate value theorem says that if you're going to go from A to B, you got to cross over every single other point in between. So we're going from positive 16 all the way down to -1. So we've got to cross over 4 somewhere, some way, somehow. Now, that's an in-depth question. I'm trying to set you guys up for what we're going to experience when we get to April and we're studying for the AP exam. Because they will ask you to invoke both the mean value theorem and the intermediate value theorem and know when to apply them, which means you truly need to understand what the heck they even say. So the question right now is, what are you thinking? What do you think you're going to score on that exam?